Hi class, Mr. Falstrom here with yet another video, and in this lesson we are going to be investigating unit cubes and volume. So your learning goal is, in this video you are going to learn about unit cubes and how they can be used to build solid figures, and then we are going to count unit cubes to calculate the volume of three-dimensional objects. And volume is a new math concept. It's new in fifth grade. There's nothing that in fourth grade or third grade or any of the earlier grades that talks about volume at all. It's brand new. So this is I'm guessing for many of you, maybe you've heard of it, but for most of you, this is probably your first time hearing about volume during math. And the definition of volume, it's the measurement of how much space a solid three-dimensional figure takes up, and it's measured in cubic units. You will hear me talk about cubic units quite a bit in this video. And let's talk about unit cubes. So a unit cube is a three-dimensional cube, and its measurements, it has a length, a width, and a height measurement of 1 unit. So if you look at that picture, the length is 1 unit, the width is 1 unit, the height is 1 unit. So everything on it is the same. All three dimensions are 1. Each side is 1 unit long. Volume is the measurement of the amount of space a solid three-dimensional figure occupies. And one way that we measure the volume of something is by seeing how many unit cubes fit inside of the shape. So if you look at the picture on the right, there is a rectangular prism, and we're seeing how many of these 1 centimeter unit cubes will fill the prism. And if we put them all in, 16 cubes fill it up, which means that prism has a volume of 16 cubic units. Or in this case, since the measurement of the unit cube is in centimeters, we would say it's 16 cubic centimeters. It's whatever the unit is. If the unit cube is feet, measured in feet or inches or whatever, that's the units that we'll use. So before we really jump into volume, I think it's important that we first kind of talk about area and talk about the differences between area and volume. So area is the amount of space inside of a flat two-dimensional shape, and area is measured in square units. So for example, if we took this rectangle and we looked at the dimensions of this rectangle, it's 2 units wide, it's 6 units long. And if we wanted to know how many square units fill up the rectangle, you can do 2 things. One, we can just count them because this isn't, there's not that many. Or you could multiply to find the area. In this case, you'd multiply the length times the width. And it gives us an area of 12 square units. 2 units times 6 units, 12 square units. You might notice under there, I say the area, for the way I write square units is I write units with an exponent of 2. You got to remember exponents. It's something else that was new for us in 5th grade. Those don't go away. They do pop up here and there. So you might wonder, how come I can write, why is there an exponent of 2 next to units? Well, units times units is the same thing as units with an exponent of 2, right? The exponent of 2 means that you're multiplying that base 2 times. So the units is the base, units times units, I can write it as units squared. So again, volume is pretty similar. Areas with 2-dimensional shapes. Volume is the measurement of space inside of a 3D figure. Instead of square units, it's measured in cubic units. And so the example here would be, we have a 3-dimensional rectangular prism, and we have, if we look at the dimensions here, it has 3 dimensions. It's 4 units long, it's 3 units tall, and it's 1 unit wide. And if, same thing, this is not a very big prism, we could count the unit cubes to find the volume, we could also multiply those three numbers. In this case, if we do 4 units times 3 units times 1 unit, we get an area of 12 cubic units. You could also just count the cubes and you could count 12. Cubic units, we have an exponent of 3. And that's because we're multiplying 3 dimensions, right? Units times units times units is units with an exponent of 3. And a nickname for anything with an exponent of 3, you would say it's cubed. So we'd say 12 cubic units or 12 units cubed. They mean the same thing. So a unit cube, since everything on it measures 1 unit, the volume of a unit cube, it has a volume of 1 cubic unit, right? So 1 unit wide, 1 unit long, 1 unit in height. So 1 times 1 times 1, it gives us a volume of 1. Because we multiplied the units, the unit 3 times, we're writing it as cubic units. So 1 unit cube has a volume equal to 1 cubic unit. And now we're going to talk about just calculating the volume of simple 3D figures. And so if a solid figure is made using unit cubes, the way we would calculate the volume is we're just going to count the number of unit cubes that were used to make up the shape. So in this case, can you count the cubes and tell me what the volume of this shape on the right is? And if you count them all up, you would get an answer of, I count 1, 2, 3, 4, 5, 6, 7, 8, 9. I get a volume of 9 cubic units. And we're going to practice. So again, we're just practicing counting the cubes. Okay, please tell me the volume of this 3-dimensional figure. And if you counted up all of the unit cubes, remember the volume of 1 cube is 1 cubic unit. Since there are 6 cubes here, the total volume is 6 cubic units. Let's do another one. Okay, what is the volume of this figure? And the answer is 8 cubic units. Again, 1 unit cube. Since this is made out of unit cubes, you're just counting cubes. Because the volume of 1 cube is 1 cubic unit, there are 8 cubes here. So the volume is 8 cubic units. How about this one? And the answer is 10 cubic units. Same thing. If it's made out of unit cubes, you just count the cubes. And one more. And the answer to this one is 8 cubic units. So this isn't too bad, right? If you have simple shapes like this that are made out of cubes, to get the volume, you're just going to count the cubes. Pretty fun, actually, I think. Here's one more. And this one had 5 cubes, so its volume is 5 cubic units. And this one has 9 cubic units. So hopefully you're feeling pretty good so far with this. I know I threw a bunch of new information at you with area and volume and unit cubes and whatnot, but this is not too bad. So now we're gonna take it up a notch, and some figures might have hidden unit cubes that you can't see. All of the practice ones that we just did, it was very easy to see all of the cubes and count them, but you might see things that look like this. So how many cubes are there? Do you know how many cubes are used to build this prism? And the answer is there's 8 unit cubes. You can only see 7 of them there, which means one of them is hidden. So if we look right here, there's a cube, there's our second cube, our third cube, and our fourth cube. So if you look at just the front of this shape, the front is made out of 4 cubes. And then in the back, we can see 3 more. There's one there on the bottom, there's one there, and there's one there. But there's one in that bottom left in the back that we can't see. So the 8th cube is hidden. You have to kind of realize that it's there. So we're going to do some practice with some figures built with unit cubes, but some of the cubes you're not going to be able to tell. You're not going to be able to see them, and you're going to have to look at them carefully and tell me the correct volume. I believe in you. So can you tell me the volume for this three-dimensional figure? And the correct answer is, it is 7 cubic units. You can only see 6 of them. If I kind of make this one cube transparent, you can see where the hidden cube was on the bottom. So if you, hopefully that makes it a little more clear for you. If you are confused about the hidden cubes, you have to really visualize it in your mind and try and realize that there's cubes that you might not always be able to see. Let's do some more. So go ahead and tell me the total volume for this three-dimensional figure. And the correct volume is, so if you see there was a whole row, there's a bunch of hidden ones, and so the correct answer would be 12 cubic units. How about this one? How many unit cubes were used to build this figure? What is the volume? And remember, if I make that cube transparent, you can see the other one. So the correct answer would be 13 cubic units. And how about this one? So the correct volume of this figure, remember there's that one you can't see. So the correct volume would be 7. There would be 4 cubes on the bottom and then the 3 cubes on the top. So 7 cubic units. How about this guy? On this one, I am not going to show you where the hidden ones are. And so the correct answer would be 11 cubic units. So there we go. Okay. Now I want to talk a little bit about layers. Many rectangular prisms are made out of layers of unit cubes. And when I say layers, you want to think of layers like floors or levels. So some examples of layers, like this cake is made out of layers. There's 4 different layers in the cake. So it's kind of like floors, like on a building. Like, hey, I'm on the first floor, I'm on the second floor, the third floor. Okay. Another good example of a building that has floors would be like a parking garage, right? Like, hey, where'd you park your car? Oh, I'm on the second floor, the second layer. I'm on the top layer. I'm on the bottom layer. So you want to think of it like that. And we're going to look at some unit cubes. We're going to look at some prisms, and we're going to kind of look at them and try and see if we can see the different layers. Okay, so let's practice with layers. How many layers are in this rectangular prism? That's right, there are 2 layers. So if I change the colors, you can see we have basically 2 floors in this prism. We have a bottom layer, and then we have a second upper layer. How many cubes are there in each layer? And there are 12 cubes in each layer. And so if there are 12 cubes in each layer, what is the total volume of this prism? And the total volume of this prism is 24 cubic units. And you could have found that out 2 different ways. You could have added 12 plus 12, or you could have done 12 times 2. Let's try some more prisms. How many layers are in this rectangular prism? That's right. Just like the last one, this one only has 2 layers. It only has a height of 2. And how many cubes are in each layer? That's right. If you count the cubes, you could count them. If I just look at this top layer and I count them, I would get an answer of 9. Or you could have multiplied. You could have done 3 times 3. You could have multiplied the length and the width and gotten 9 cubes. So there's 9 cubes in a layer. What's the total volume of the prism? And the total volume would be 18. And again, you could have either added 9 plus 9, or you could have done 9 times 2. And I'd like to point out that when we split the shape into layers, this makes it way easier, because if you look at that bottom layer, look at all the hidden cubes we can't see. We can only see the total amount of cubes on the top layer. So if we can count all the cubes in that layer, we can figure out how many layers there are and still figure out the total volume pretty fast. So you could have done 9 plus 9, or the 9 times 2. How many layers are in this rectangular prism? And there are 4 layers. And so you can probably guess what the next question is. How many cubes are in each layer? And the correct answer for that is there are 4 cubes in each layer. So if we know the amount of cubes in one layer, we can use that to find out the total volume of all of the prism by looking at all of the layers. So what is the total volume? It is 16 cubic units, and you could have done 4 plus 4 plus 4 plus 4, or you could have simply did 4 times 4. And that would give you an answer of 16. So let's circle back now to the learning goal, which might have sounded confusing at the beginning of this video, but let's see if it makes more sense now. Our goal was to learn about unit cubes. So ask yourself, do I know what a unit cube is now? Does it make more sense? Like if, a unit cube is a cube where the length, the width, and the height all measure 1. And then we looked at how unit cubes can be put together to make different 3-dimensional solid figures. And then we practice counting unit cubes to calculate volume. So kind of look at this and go, okay, does this make more sense to you now? How do you feel with this? Do you feel like you're doing all right on the questions? Is it making sense? If not, again, maybe rewind the video and watch it again. And if you still aren't sure, that's what we have our Zoom meetings for, our classes. So come to class and ask some questions. Say, hey, Mr. Falstrom, I didn't understand this part. Can you explain it to me? So let's recap unit cubes and volume. So a unit cube is a 3-dimensional cube. It has a length, width, and height of 1 unit. Unit cubes are used to measure volume. And the definition of volume, it's the amount of space that a 3-dimensional figure occupies. It's measured in cubic units. It's similar to area, which is measured in square units. Remember, area is for 2-dimensional shapes. Volume is for 3-dimensional. And for objects that are made out of unit cubes, you can just count the cubes to find the volume. Sometimes cubes are hidden from view. And some three-dimensional figures are made out of layers of unit cubes, and we can find the total volume by figuring out the amount of cubes there are in each layer and either adding all of those together or by multiplying how many are in one layer by the number of layers. And speaking of cubic units and unit cubes, I wanted to show this video. This is a place in the Netherlands, and they actually built these houses that people live in that are shaped like cubes. And they're really cool looking. They were made in the 1980s, and you're going to get to see what they look like inside. But when I think of unit cubes, I always end up thinking about these houses. They look so interesting and yet confusing, but very, very cool. And I definitely, if I ever go to the Netherlands, I would like to maybe visit these and actually walk inside and see what it actually looks like. It's so much more different than the regular types of houses that we see in everywhere. These are very interesting. So now you're getting to see what some of them look like inside. It looks almost a little confusing. I feel like I maybe get dizzy. Very interesting though. I don't know if I would want to live in one, like for a long time, but I think, if I got to like stay the night in one, just for a night or two, I think that would be fun. I don't know. I don't know if I would. I guess you'd get used to it if you. I guess if you live there, after a while, it'd be normal. So now that you kind of got to see a view, I'm kind of curious to just ask you: would you enjoy living in one of these houses? Do you think you would like it? And that's the end of this video. This was sort of your introduction to volume. We're going to do a lot more stuff with volume. So now we're finally at the part of the chapter where we're going to be using some numbers and not just talking about words and polygons and polyhedrons and all those things. We're going to start using numbers to calculate the volume of different prisms. So thanks for watching, and I'll see you again on the next video.